Hello everyone. Now in this video we are going to see one more case of line inclined to both the planes projections. As on the screen you can see that a line PQ 80 mm long measures its top view as 65 mm and the front view as 55 mm, whereas its end P is 30 mm above HP and 35 mm in front of VP. Draw the projections of the line and determine apparent lengths and inclinations. If you observe carefully, in the question they gave the true length of the line is 80 mm. The true length is 80 mm. And two more distances they gave is that when you see the true length from the top, it measures as 65 mm. When the same line views from the front side, it measures as 55 mm. That it indicates this line is inclined to both the planes. You can see now. So this is the true length of the line 80 mm. When you see from the top, it measures as 65 mm. That's what front view is A dash, B dash is the true length, AB shortened length is 65 mm. When a line is inclined to vertical plane pi, when a line is inclined to vertical plane, the top view is a true length 80 mm. But when you see from the front side, it appears as a 55 mm. So in this case they gave two cases. It says that the line is inclined to both the planes. So as already we discussed in the previous tutorial, how to solve the line inclined to both the planes and how to draw its projections. The same procedure we are going to apply now. First, we will write the given true length is 80 mm. Top view length 65 mm. Front view length 55 mm. Yeah. The true length is 80 mm, top view length is 65 mm, front view as 55 mm. And two more cases. The end P is 30 mm above HP and 35 mm in front of VP. Yes. Now I am drawing this one. 30 mm above HP, 35 mm in front of VP. Perfect. Yes. Now I drawn the end positions P. Okay. How to draw the next one? To measure this as 65 mm, the top view length 65 mm, the line should be inclined to HP. In the previous cases, they gave the values of theta, that is inclined to HP angle they gave. But in this question, straight away they gave the projection length, not the theta. How to do? So now we are going to draw in the reverse case. First we will draw the projection and then we will draw the true length line. The top view length as 65 mm. You can see here the top view appears here in front of VP distance. In front of VP The top view appears as 65 mm. 65. Yes, 65 mm. I made it. Now I am drawing a projector from here. Okay, just I drawn a projector, and now I am going to draw the true length. Take the circle, and this as the center. The radius is 80. See, this is the point. So from here, this is the end P and this is the end Q. Text P dash, Q dash, P, and then Q. Okay, if you observe carefully, the first point is split the question into two parts: horizontal inclination and vertical inclination. Now you can see that we drawn the projections of the horizontal inclination. When a line is inclined to HP, the front view appears as a true length, top view appears as a shortened length, that is 65 mm. So the second case finished. Okay, now one more case is that the line is inclined to VP. How to draw? So the top view 65 we finished. Now the front view 55 mm we need to draw. You can see when the front view is 55 mm, this line should be inclined to vertical plane. This is true length 80 mm. From here 55 mm and draw the projector, and this is the center. The radius is 80. From here to here. Yes. Okay, already we finished this horizontal inclination. Now Q1, because I am taking the new notation for the vertical plane inclination, Q1 dash. Okay, perfect. We can give the dimensions. See, the 80 mm length in the top view measures as 65 mm. Very good. The top true length 80 mm in the front view measures as 55 mm. Perfect. We drawn everything. Now it's time to draw the projections. So first case finished. Draw its projections, front view and top view we finished. Now it's time to note the true and shortened views. If you observe carefully, when a line is inclined to HP, the front view is a true length, so that's why I am taking it as true front view. And the top view is a shortened length, that's why I am taking it as shortened top view. True front view, I am just marking it as P dash Q dash. See, true front view is P dash Q dash and its corresponding top view is the shortened one. So shortened top view is PQ. Okay. Now, one more case is when a line is inclined to VP, the front view appears as a shortened one. So that's why I'm taking it as a shortened front view. But when you see from the top, the line 80 mm represents the same true length. So that's why true top view. Now, true top view is PQ1. Shortened front view is P1 P dash Q1 dash. P dash Q1 dash. Shortened front view. Perfect. Now we finished this one also. Okay. The next one, fourth one. Rotate short front view to true front view locus. Next one is rotate shortened top view to true top view locus. So before noting this, doing this one, we need to draw the locus. I am drawing the locus of Q dash. Locus of Q1. Locus of Q dash. Okay. Again, I am drawing a line from here. So this is locus of P dash and this is locus of P and this is locus of Q1. I am going to edit it now. Locus of P dash, locus of Q, locus of Q1. Okay, perfect. Now we draw the locus lines also. Next, fourth one, rotate shortened front view to true front view locus. So this is the shortened front view. We note it down here, P dash Q1 dash. Shortened front view to true front view locus. True front view is P dash Q dash. So I am taking the arc A, enter, center. This will be the center and the radius is P dash Q1 dash. See, I am rotated till here. Arc, enter, center. This is the radius. Yeah, it meets the point here. Okay. Next one is rotate the shortened top view to true top view locus. You can see that this is the shortened top view is PQ. Shortened top view is PQ and I am rotating into the true top view PQ1. Arc, enter, center. Take this as the point and this as the radius. Now press Ctrl for the reverse direction. Yes, now it cuts here. So these are the final points, means projections, final top view projection cutting point and final front view. So to do this one, draw a line P dash 2 here and here. Okay, so to confirm whether we made it correct or not, draw a line from the point to, from this point it appears as a see, perfectly it cuts here and that too this line will appear as a straight vertical line. It is the projector between the front view and top view. This is the projector which matches orthogonally. Very good. So we are going to trim this one. I am trimming it. Okay. Yes. Now this is the final front view and final top view. So we'll mark it as Q2 dash and this one as the Q2. That's it. So we drawn the final front view and final top view. As in the question they asked that determine apparent lengths and inclinations. So this is the apparent length 55. Is the answer. Yeah, it's in position only, means the answer is exactly 55 and 65. So draw the line to show the final projections we finished and measure the alpha beta, which is apparent inclinations, DAN, dimension angular. First we'll check it out the true inclination. This is the apparent, this is the true inclination. This is theta, 36 is theta, and this one is the apparent inclination 58. Alpha equals to 58. And now the angle between the true length, this is pi equals to 47 degrees. Now we are measuring the beta, apparent inclination, beta equals to 61 degrees. Okay, the alpha equals to 58 degrees, beta equals to 61 degrees. So we finished everything. To make it good, we'll just trim this portion.